Okay, let's take a look at this practice, chapter 2, practice exam. If you can do this, you will do very well on the actual chapter 2 exam. So guaranteed to see a problem where the quadratic will be in vertex form. So when I see vertex form, I know instantly, I can look at this, I can see this x minus 2. I know it's to the right 2, which makes it a positive 2x value. And then the number on the outside is my y value, my vertex. So the first point that I'm going to plot is I'm going to go over 2, down 1, 2, 3, 4. Okay, so I know that is 1 point on my graph. Okay, since the number in front, it's a vertical stretch, but it's positive, we know we're going to have a minimum. Okay. And our minimum y value is going to be -4. That's going to be useful when we have to state the range. We also know that the line of symmetry, the line that's going to cut this u in half, is going to be x equals 2. Okay, so if you need to, we can use a calculator then. I'm just going to go to my y equals screen. And then I'm just going to type in the rule exactly how I see it. So 3 parentheses x minus 2, close the parentheses, squared, and then -4. I hit graph. I can see what the graph's going to look like. And then the most important thing is go to your table. So when I go second graph, I want to position my table so I can see the vertex and 2 dots above it and 2 points below it. So I see 0, 8. So I know when x is 0, y is 8. Again, if you don't like a calculator, then you have to plug in inputs yourself and do the calculation, okay? You'll still get an 8. You can use the idea of symmetry. So if you go over 4, you're also going to be up 8. And then we'll just do the point 1, -1. And then we're going to see 3, -1. Okay, so 5 dots is what I'm going to ask you to do in your exam. Connect the dots, show that it goes up forever, and then connect this side, goes up forever. Okay, then the remaining questions here, you know domain's going to be all reals. Okay, so right now with quadratics, you can use any input. My range, since my minimum y value is -4, you're going to see everything else is going to be equal or above -4. And you can see that from our table. Okay, all those y values, if this is my lowest, all the other y values are going to be above it. And then this question, please don't get this wrong. Whenever it's a minimum, it's decreasing on the left. And then once we hit this, then it increases on the right. And again, you must look at this left to right. So I'm traveling, I'm going down on the left, then I go up on the right side of the vertex. Okay? So then this next problem is in standard form. Okay? So with standard form, you can't just look at those numbers and know instantly what the vertex is, but it doesn't take that much work if you pick out your A value. Okay? So A is negative, I know we're going to have a maximum in this case. Okay? I can tell that right away. And then my B value is -8. And I'm going to do this little phrase. I'll have it up on the board. Most likely I'll write it on your exam. Opposite of B over 2A. So in this case, it's going to be a +8. So opposite of -8 is a +8 over 2 times -2. If you do that, again, if you're going to use a calculator, make sure this goes, the bottom goes in parentheses. You also know it's 8 divided by -4, which is just simply going to be a -2. Okay, so since we know x is -2, we know -2 is going to be our x value of your vertex. So all we have to do is go to the y equals screen. I already have this typed in, -2x squared minus 8x minus 4. Again, don't miscopy. And I just need to go to my table and find -2. Okay, and when we position our table to see -2, you see the idea of symmetry. So I'm going to plot, the first point I'm going to plot is -2, 4. That's my vertex. Okay, so -2 up 1, 2, 3, 4. there's my maximum, and we know the maximum y value is a 4 this time. We know our line of symmetry is going to be x equals -2. So I just need to gather 2 dots above it and 2 dots below it, and we'll see the idea of symmetry. So -3, you're up to 2. You'll see -1 also gives you that same outcome of 2. And then we'll also plot -4 down 4. 1, 2, 3, 4. And then you'll see 0, -4. Okay, nice. Just connect the dots, and you'll see a parabola that opens down. Okay, so we know the domain is all reals. We know the range this time are all y values less than or equal to 4. So if 4 is the max, all the other y values are going to be below it. And now I'm going uphill left to right on the left. So I'm increasing on the left, decreasing on the right. Okay, remember, these are going to be worth 10 points each. So again, make sure you're careful, type it in, find the vertex, and it should be very easy to do. Okay, this next problem is an inequality. So the first thing we need to notice is we are going to have a dotted or dashed parabola. Okay, there's no equal to. So first thing, just realize is going to be dashed. And then the second thing, just realize once we get our points for our parabola, we are going to shade above. So shade above, and the reason I know that is that's a greater than sign. My outcomes are greater than. Okay, so before I pick up my calculator, I'm just going to do the opposite of b. So b is 16 over 2 times -2. I'm just going to do this calculation in my head. It's going to be -16 divided by -4, which is going to become a +4. So I'm going to have a line of symmetry when x is 4. That's where I'm going to go to my table after I type this into my calculator. -2x squared plus 16x minus 31. I can see what the graph looks like. Okay, I know it's going to be a reflection, so it's going to open down. And I'm just going to position my table. On my table, I need to reset this. We're going to go by ones. So when I go to my table, I can see when x is 4, y is 1. Okay, that's going to be my maximum. Okay, so I just need to put a dot there. And then use the idea of symmetry. We have 3, -1. We have 5, -1. And then I'm going to do 2, -7. So when x is 2, 1, 2, 3, 4, 5, 6, 7. And then we can use the idea of symmetry, reflect it, so that when we know when x is 6, we also have that same outcome of -7. Okay? So now, again, get the 5 dots, and then know in this case, I'm going to connect it with a dashed curve. Okay, my graph has to be dotted or dashed. And then I am going to be shading all the points above. Okay, so and how you could test this is pick a point above, like 0, 0. If you replace the y with a 0 and these x's with 0, you get a true statement. 0 is going to be larger than -31. Okay, but it wouldn't matter what order pair you plug into this original problem, it will be a true statement. Any points below would be a false statement. Okay, this next one, the good news about this next one is it is in vertex form. Okay, so we're still going to use a calculator, but we need to realize it's going to be a solid parabola and it's going to be shaded above. Okay, so we're going to shade above. Okay, so I know instantly without a calculator that it's to the left 3 and up 2. So that's going to be my starting point. Now I'll put this rule into my calculator. Oops, hit clear, and I'm going to type in parentheses x plus 3 squared and then plus 2. I'm just going to go to my table. I know to go to -3, and then I can see from my table this idea of symmetry. So we already plotted negative 3, 2. I knew that just from the rule, but now I'm going to plot negative 4 up to the 3. Use the idea of symmetry. Negative 2 will give you that same outcome of 3. And then we'll plug in a negative 1, go all the way up to 6. And then same thing with negative 5. We're all the way up at 6. There's my 5 dots. That's all you're going to need to do on your exam. Plot your 5 points. This time connect them with a solid. And then above are all these points right here. Okay? So that's all it is for quadratic inequalities. Plot your 5 points. Know if you're going to connect with a solid or dashed or dotted, and then know how to shade above or below. Okay? That's all it is to graph inequalities. Okay, this next page, this next problem, made you do this on your chapter 1. So chapter 2, we're just going to make sure it's quadratic this time. No absolute values or other types of functions. So the first thing we're going to do is we're going to write a rule g, so g of x. We're going to translate 10 units to the left. So as soon as you realize it's 10 units to the left, I need to go to where the input is, and I'm going to add 10. Okay? And then once I move 10 units to the left, I'm going to do 9 units up. And that's all I need is to put a plus 9. So its vertex, if I actually graph this, I know the vertex is negative 10, because to the left 10, and then positive 9 for the y value. So negative 10 comma 9 would be the vertex if I ask for that. Okay? So now go back to the original. Okay, we're not going to use this anymore, so we're going to write a function h this time, where it's a vertical shrink with a factor of 1/2 and reflected about the x-axis. So again, in one move, we can have both those movements because you're going to multiply by negative 1/4. Okay, you just take this x squared, the reflection would just be the negative, and then the shrink is, why did I say 1/4? It's a 1/2. My eyeballs. So that's a 1/2. Okay, so negative 1/2 x squared. Okay, this next part, I just want you to be aware of how we can make a graph wider, how we're going to make it narrower, and so on. So write an equation of a quadratic whose graph would be wider than f. So you put any number, okay, it's up to you, any number between 0 and 1. So I'm going to stick with, here, this time I'll do a 1/4. So we'll call this g of x, and I'm going to put a 1/2 in front. So really, if I simplify this, it's going to be a 1/2 x squared minus 7/2. Okay? Whatever your number is, you have to then multiply everything from this rule. So the whole entire rule needs to be multiplied by whatever number you have between 0 and 1, and I promise you that's going to shrink your graph, thus making it wider. Okay? So if I want to then, for number 8, write an equation that is going to be narrower, I just make sure I put a number in front that's greater than 1. So if I really wanted to make it really skinny, I'll put like a number like 10. So 10x squared minus 7, but it can be any number you want. Even 1.1 would make it more narrower than the original. So as long as your number is greater than 1, it'll be fine. I'm going to simplify this. I'm going to write 10x squared minus 70. Just remember to distribute that number. And then it says write an equation of a quadratic whose graph would be the same axis of symmetry. Okay, so what I need you to understand is, as long as you don't change anything to your x, you can't move it left or right. So right now, this, you can even see it. I'll type it into my calculator. So if I type in x squared minus 7, I know my vertex is 0, negative 7. I'm going to know it's down here. So right there is 0, negative 6. So to keep this line of symmetry, all I need to do is change the minus 7 to whatever number I want. So I'll do W of X just to be different. And you can keep the X squared, can't shift it left or right. Okay, keep that axis symmetry. You can make it a reflection. Okay, I could have it reflected and it still will be the same axis symmetry. So I'll give you several examples. I'll change this. So I put a +2. So again, if I go here just to prove X squared plus 2 would have the same axis of symmetry. I'm just moving it around. I could reflect it. So there's a lot of different things. I could have negative X squared and then change that number or keep it the same, negative X squared plus 7. Lots of different answers for that problem, okay? So now we get to a word problem involving a quadratic. So anytime you're given a word problem, make sense of your inputs and your outputs, okay? So we're dealing with the height in meters of, that's our outcome, of a water sprayer from a fire hose that can be modeled by this, where X is the horizontal distance, okay? So the first thing we need to do is figure out the vertex of this. So this is standard form, okay? So the first thing I'm going to do is opposite of B over 2A for this problem. So in this particular example, my B value is 6, so I'm going to have negative 6 over 2 times negative 0.25. Okay, and I want to do this calculation before I pick up my calculator and go to the y equals screen. So remember, when you're go to the blank screen. When you're doing the opposite of b over 2a on a calculator, the denominator must be in parentheses. So it's negative 6 divided by 2 times negative 0.25. I get an answer of 12. Okay, that's just going to help me when I go to my table. I know to look for when X is 12. So that tells me 12 meters from the fire truck horizontally is where, if we could freeze the water and look up and measure the height, that's going to be where the max occurs. Okay, so I'm just going to type this rule in, cleared my 2 previous graphs, and I'm just going to go negative 0.25 X squared and then plus 6X. Relatively easy to graph, and then I'm just going to go to my table, scroll to 12, or you could jump to 12. Remember, second Windows brings up a table set, and then I'm going to know the height, and you can even see it starts coming back down at 13. So my max is when X is 12, my Y is 36. So 12 meters from the fire truck, it reaches the max height of 36 meters. Okay, so just try to visualize that. You can, if you needed to, you could draw a picture to show that path of that water, and it's peaking at 12 horizontally and up 36. Okay, so then I have this question. A second sprayer sprays water, so a second hose sprays water on a path that has a vertex of 1040. Okay, which hose will spray higher? So obviously this 40, so you're comparing 36 to 40, the height, the Y values. Again, know what your inputs are, know what your X values. So fire truck 1 is 36, fire truck 2 is 40, so the second hose is higher, okay, by 4 meters. So the second hose is higher, and then it says, from which hose will the water travel farthest away from the truck? Okay, so then that's where you're comparing the 12. So really, if it takes 12 to reach it, it's going to hit the ground and travel to 24. Okay, I need you to understand for the first truck, if it takes, got a whole idea of symmetry, it goes from 0, 12 this way, then it's going to take another 12 meters to then hit the ground, as opposed to this where it's only 10 to reach its max height of 40, but then it's going to come back down at 20. So you're comparing 24 to 20. The first hose travels farther. Okay, not higher, farther horizontally. Okay, and again, just force your brain to see that path and understand what's happening with that parabola. Okay, so little word application problem that hopefully you can make sense of and reason out. You need to, use your calculator, graph this to understand why it's going to come down. I can show it right here. At 24 is going to come back and hit the ground. Okay, so it's leaving the hose at the ground and then shoots up and comes back 24 meters from where it started. Okay, so make sure you can understand those problems. Okay, this next problem, number 12, we can clearly see this is a linear situation. So I'm going back to chapter 1 to just review a concept of linear situations where I'm going to ask you to write an equation. So again, if you forgot all about this, just want to quickly review something, especially if you have to take the Keystone. This is stuff that you had to learn in Algebra 1. So I have a linear situation where x is time, and then your y is your total cost. So your slope is going to be the y's over your x's. Okay, that's what you're comparing. So cost per hour. That's what we can easily calculate when I look at my input and my output. So I tell you, at one point, we rent a canoe for 5 hours, it's $45. Well, here we rented a canoe for 2 hours and our bill is $30. That is enough information. We reviewed this on that opening worksheet, how to find a slope given 2 points. I take the differences in my y values, so 45 minus 30, that goes on top. That's going to be a 15. And then I do the corresponding x values. So I started with 45, I must say 5 minus 2, which is 3. And it makes sense that I have a positive slope, which in the context of this problem, it means I'm paying $5 per hour, okay, to rent a canoe. That's my slope. And so to write my rule, y equals mx plus b. Well, we already calculated this slope. Slope is $5 per hour. And the good news is I don't have to work to find what my starting point is. I can clearly see it starts at $20. So just to be able to get the canoe, you're paying $20. You didn't even, you just received it. It cost $20, but then each additional hour is going to bump it up by $5. Okay, so that's what the story of this linear situation is telling. So then what is the cost to rent a canoe for 7 hours? That's using our rule that we can go off this chart. Okay, so if if this was expanded more, I could just use this graph, but since it looks like it ends at 6, we can be more accurate by simply plugging in a 7. Again, x is hours, okay, time in hours. Replace my x with a 7, and then it should be a simple calculation to know that it's going to cost $55 to rent this particular canoe for 7 hours. Okay, so then I have another application problem. This time it's in standard form, and once again we have to understand from the context of this what your inputs are. So each month the number of animals in thousands at a local is modeled by this, where m equals 1 corresponds to January. So when I type this in, I'm just going to simply go to my y equals screen, type in 2.75 x squared. So again, my x is months starting with January. So 2.75 minus 33x plus 130. Okay, I want my table to start at 1. So I just want to start at 1. And here's how I can read this. Okay, in January, we had 99.75 thousand animals, okay? And you can see that the animals, the population is decreasing each month, okay? It's still going down, but then in June, it reached its lowest point. It reached its lowest point, and then we start to rebound, okay? Then you can see that we're coming back up, okay? That's how we have to read this table, where this is months, starting with January. So January, February, March, April, May, and so on. And then your Y's are the number of animals according to, in thousands. So the first question is, how many animals are located in January? Well, we know 99.75 thousand. Okay, I'm just going to write it like that. So as long as you realize it's in thousands, move that decimal point 3 places. Okay, if you needed to. So I'm fine with 99.75 thousand animals. And then October is the 10th month of the year. We have 75,000. Okay? Pretty easy to interpret this chart. Okay? When is the population 42,000? Okay, I can see it actually occurs twice. I can see whoops, you can't see that, but let me show on my table. 42 occurs in the 4th month, which is April, and then it also occurs the 8th month, which is August. Okay, so again, interpret this table. That's so much of math is understanding inputs and outputs for a particular situation, okay? And then what is the lowest population? Well, that occurred at my vertex, which we know is in June. So what is the lowest population? Well, that's just when we had 31,000 animals, okay? And then in what month did it occur? It was the 6th month, which is June. I should be able to spell June. Okay, that hopefully makes sense. You just had to rely on your calculator and understand your inputs, understand your outputs to answer that question. Okay, so with these problems, I promised you that on your exam, I'll write the particular formula that you need. Okay, so for this, we are given a vertex, so what you're going to see is y equals a times x minus h squared plus k. Okay, so again, you're only going to have one of these. I'm having you practice 2 of these. So you have to go into your exam knowing the second you see vertex, you're going to label it hk. Okay, then your point, your just random dot that's on that particular parabola, is going to be labeled xy. So then all you have to do is substitute into this formula, this rule. So I'm going to replace the y with -4. I don't know what a is. We're going to solve for it, and it won't take too long to solve. I have my a minus my h. I'm going to have to square that, so don't forget to square. And then minus 8 on the outside. Okay, so my first thing I'm going to do is calculate this part. So 3 minus 7 is -4, and -4 is 16. So it's a16. I'm going to write it as 16a. I just think it looks better. And then I have 2 steps to solve for a. So I'm just going to add an 8 to both sides of my equal sign. That gives me a +4. And I'm going to divide by 16. Don't allow yourself to think that that's equal to 4. This is going to be a vertical shrink by a factor of 1/4. Okay, so a is 1/4. 4 out of 16, you can use the calculator if you need to. It'll be 0.25, which is 1/4 as a fraction. And now, don't forget to write your rule. Yes, you need to know what a is, and we were able to get 1/4, but I need to write a rule that shows someone, hey, we have a vertical shrink. The number in front is less than between 0 and 1. And then I have x minus 7 squared minus 8. Someone looking at your rule in vertex form should clearly see your vertex. It's to the right 7, that's why it's a positive 7, and then down 8, that's why we have a minus 8 for the y value. Okay? Same thing occurs for number 15. Label h, k, x, y. This time it's y equals a times negative 4 plus 2. Okay, so don't allow a minus and negative to confuse you. So minus a negative 2 is plus 2, so I'm just going to write it as plus 2 right away. And then I have up 5, which is plus 5. Okay, so again, calculate what's inside. That's going to be a negative 2, but negative 2 squared is going to be a 4. A times 4, which is really 4a. And then I have my plus 5 in 2 steps. So first step, subtract 5. You get negative 4 equals 4a. Divide by 4, and you're going to see that we have a reflection. Okay, so negative 4 divided by 4 is negative 1. You can put a negative 1. I'm just going to put a negative in front. And then it's going to be x plus 2 squared plus 5. And again, this 2 and this 5 help me understand what our original vertex is. Okay, so not too bad. You're only going to have to do one of those. And then our next form is intercept form. And again, I will provide this for you. Okay, I'll have this so you won't get confused between the two forms, vertex form and intercept form. Here in intercept form, I must tell you the two intercepts. Okay, so it crosses the x-axis at 3 and negative 6. So one of them's P, the other one's Q. And then some random point is 0, 90. So I plug all those values into this. My y value is 90. The a we don't know, but my x is 0. So we have 0 minus 3. And then we have 0 minus negative 6 is going to become a plus 6. Okay? 90 equals a times, and I'll write this out. Okay? So here you get negative 3. Here we get a 6. So multiply that together, we get negative 18. So we're going to have to take 90. 90 divided by negative 18. And we're going to see that it comes out to a negative 5. So it's going to be an upside down U. It's going to be a little bit skinnier. It's going to be also a vertical stretch because that number 5 is greater than 1. So write your rule, put the negative 5 out front, and then we have an x minus 3, and we have an x plus 6. Okay, again, you could type that in your calculator if you had time, and just double check to make sure you see 3, 0 in your table, negative 6, 0, that's where it's crossing the x-axis, and 0, 90. Okay, so that's all we're doing at this point. Okay, last one, P, Q, X, Y. Y is 18. The A I don't know. My X is 2. We're going to have 2 minus negative 1, which is 2 plus 1. And then 2 minus negative 4 is going to be 2 plus 4. Pretty easy to simplify this. Again, don't make mistakes with calculations. If you need to, use a calculator. But I'm going to know that 3 times 6 is 18. When I divide by 18, I see that is just a 1. Okay, so not a stretch, not a shrink. And my final answer is just going to be x plus 1, x plus 4. And if you want to, you could put a 1 in front, but you don't need the 1. Okay, so again, that should be pretty straightforward on your exam. I'm not going to try to trick you. Pick out the critical points and substitute into either the vertex form, if I give you the vertex form, or intercept form. Okay, so hopefully that makes sense to everybody. Okay, our last page of our review, we start out with another word problem that you can just use your calculator. Okay, so again, with every word problem, know what your output is. So we're dealing with the height in feet after my input of seconds. Okay, so I'm just going to type this in, and then look at my table. So I have negative 16x, x stands for seconds, and then in parentheses I have x minus 3. Okay, so what we have to do is interpret this table, and you're going to see the vertex actually occurs in between. So I'm going to actually change my scale. I'm going to go by 0.5 to see a better look at this. So we have a water balloon that is launched, and it follows this. So it starts on the ground, we shoot it upwards. After 1 second, it's at 32. So then between 1 and 2, we know it peaks. Okay, so what I'm going to do is have my table start at 0, and I'm going to go by 0.5s and see if I can have a better look at what's happening to this graph. So after just a half second of launching it, it's reached 20 feet, and then 1 second, it's at 32. At 1.5, it looks like it reached its peak. See the idea of symmetry here? So find the vertex. Well, the vertex is going to be 1.5, and then my max height is going to be 36. Okay? So again, if you thought about this, it's going to start at the ground, and then it's going to hit the ground after 3 seconds. Halfway point in between is 1.5. Okay, and then again, we used our calculator to know this reaches its max height of 36. Okay, what is the vertex means in the context of this situation? After 1.5 seconds, that's where I would want you to label everything correctly. Know that 1.5 is seconds. It reaches max height of 36 feet. Okay, and that's kind of what Big Ideas made you do. Like once you found the vertex for a particular word problem, they just made you read a phrase and make sure you understand the full meaning of it. So then, how long does the balloon remain in the air before hitting the ground? You can see right here, it hits the ground at exactly at 3 seconds. So it's in the air for about 3 seconds. Okay, so launch it, it goes up, and you start your clock, and at 3 seconds, it's going to hit the ground. So 3 seconds. Okay, the last problem is a review of Chapter 1. I don't want you to forget the Chapter 1 content. And so this is a problem where we have to decide which letter, actually, sorry, I can see right here, we're missing the Z's. So that is our hint. No Z's in the bottom. So that kind of lets us know exactly what we're going to do with the top two equations. We're going to get the Z's to cancel out, okay? So the good news is the Z's are already opposite. So when I look at the top two equations, all I have to do is to add. So when I add, I'm going to have a negative 4x. I'm going to have a plus 4y. Z's are gone, and it's going to equal 16. So I take that new equation that we just created and then add it to the one that was already my third equation. And the good news is, once again, relatively easy problem, I don't have to work to get opposites. I already have my x's opposite, so if I add, the x's are gone. When I do this, I'm going to have a negative 8, so the x's are gone, the y's are negative 2. I divide by negative 2, and just like that, we know that y is 4. Okay, and if y is 4, I can take this, plug it back into that bottom equation. So where I see a y, I'm going to put a 4. I have negative 24 equals negative 24. When I add 24, I get 0. Now, this is in a special case. I did not have my variable cancel out. So just like that, let me move this down. X is 0. So hopefully you can see my work here. I just plugged in a 4 for y, and I was able to solve and know that x is 0, which means all I need to do is go back to one of my original equations with 3 variables. So I'm going to go back and plug it into the middle. So 2 times 0, my x is 0, plus 5 times 4,
plus 4z equals 8. Okay, so that's a 0. That's going to be a 20. And in 2 moves, I will have the z value. So this is going to give me a negative 12, divide by 4, and z is negative 3. Okay, putting everything together, write your x value first, then the y value, and then finally the z value. And how you can quickly check, plug these numbers into the original, the top. Negative 6 times 0 is 0, minus 4, so it's negative 4, and then minus 4 times negative 3 is going to be a 12. So negative 4 plus 12 is indeed an 8. So I know this ordered triple satisfies all 3 equations. Okay? So hopefully that makes sense, that you take your time, force everything on this practice to make sense. Go back and look over some big idea problems that you did. Look back over the notes. I have all the completed notes, extra examples that we didn't do together in class. You can try and look at the work. That's how you get prepared to do well on an exam. Okay, so thank you for watching. Take care.